Hello everyone and welcome to another video in the Python Fundamentals series. Today, we're going to take a look at a lesser known concept with classes called Dunder methods. This is one of my favorite things with Python since it's more or less unique to this programming language. With that said, let's get started. So, what are Dunder methods in Python classes and what can they do? Well, let's find out. You may be surprised to learn that you've been using Dunder methods for quite a long time now. Let's take a look at this example. I add 1 and 1 together using the plus sign, and I compare 1 plus 1 to 3 using the double equal sign. And here I slice the string, and on line 4, I pass the string into the len function to get its length. If I run this cell, you'll see the correct output on the screen. But have you ever wondered, what is it that allows us to put the plus sign in between two numbers to get the sum? What is it that allows us to put the two sides of an equation on the two sides of the double equal sign to compare them? What is it that allows us to slice a string or to pass a string inside a len function to get its length? Well, that's where the Dunder methods come into place. Keep in mind that classes are just new data types that we as programmers can make to suit the needs of our programs, and Python gives us the ability to use operators like the ones above to make our classes better, and this is done through what are known as Dunder methods, which stands for double underscore, double underscore, double under, Dunder. And that's because there are two underscores before and after the name of the method. In fact, you've already met one of those magic methods, which is just another name for Dunder methods, and that is the init method. The init method of a class is called whenever we make a new object. So whenever we construct a new object, the init method is called to do that. Another commonly used Dunder method is the REPR method, REPR standing for representation. Now, let's take a look at this cell right here. This is going to be the definition of a language class, which we're going to use for the rest of this video. It's got language and it has an init method. We pass in name, and the name is stored inside an instance attribute called name. Here, I make an object called L, which is an instance of the language class, name being Python, and if I print out L, you'll see this gibberish printed out onto the screen. Essentially, what this is telling us is that L is an object of class language, and it's an object, and it's at this particular memory location on my computer. Now, I don't know about you, but for me, this means absolutely nothing. So this output is useless to humans, and that's where we can use the REPR method to customize the representation of an object. The REPR method returns the string that represents the object. So in this definition of the language class, we have the same 3 lines here. I've added a REPR method definition, which returns 2 strings concatenated to each other. So the first string is a language called, and it's concatenated to the name of the language. Here I make the L1 object, which is an instance of the language class, whose name is Python. L2 has a name of C++. Now if I print out L1 and L2, we'll see a much better customized representation of those instances, a language called Python and a language called C++. So that is the power of the REPR method, and we can actually differentiate between objects using the output when we print out objects. The next Dunder method we're going to take a look at today is the EQ method, or double underscore EQ method. And whenever you use the double equal sign, the EQ method of a class is called. Let's take a look at this cell right here. L3 is a language whose name is Python. And L1, when you scroll up, you'll see its name is also Python. However, when we compare those two objects together using the double equal sign, you'll see false printed out because by default, Python checks whether two objects are the same object, so whether or not they live at the same memory location, and returns the Boolean representation of that. So even though both L3 and L1 have the name Python, they aren't the same object, which is why false is the output. We can customize the EQ method so that true can be returned if the names of the languages are the same. So here, we have the same 3 lines here, and I've added the EQ method. So underscore underscore EQ underscore underscore. And here we pass in self and other. So we're actually passing in another parameter, other. Self is the current instance of the language class that we're working with. And other is whatever is passed afterwards. So let's take a look at this example, for example. L1 is going to be self, and other is going to be L2. In this example, L1 is self, and other is L3. And we will return a boolean, which is going to be the comparison between the name of the current instance versus the name of other. I've made 3 objects, L1, L2, and L3. Their names are JavaScript, JavaScript, and Java. When I compare L1 to L2, those two both have the name JavaScript. So self.name, JavaScript, other.name, JavaScript. Those are equal to each other, so this is true, and that is going to give us a result of true. And we'll see true is the output. On the other hand, when we compare L1 to L3, so is self.name, which is JavaScript, and other.name, which is Java. Are those equal to each other? Of course not, so false is the output. The other parameter is the object which self is being compared to. And that's right, we can pass our own objects as function or method arguments. And the next method we're going to look at is the getItem method. You've probably used indexing and slicing with objects like a string, a list, a tuple, a dictionary, and we can do the same with our own objects using the getItem method. L2 is defined up here, so it's a language whose name is JavaScript. And if we try to get index 3 of L2, we will see a type error telling us that language object is not subscriptable. That means we cannot find the index of a language object. So we have to add the getItem method. So underscore underscore get item underscore underscore. It takes self and key as its parameters. Key is going to be whatever we put inside this pair of square brackets, so 5 or 818, and we will return self.name at that particular index. We make an object called L1, which is an instance of the language class. Name is structured query language, so SQL. And when we try to print out the 5th index of this language object, it's going to take a look at its name right here and find index 5. So index 5 is right here, so T is going to be the output for the first line. When we try to find a slice, a substring of L1, we'll get 8 to 18, so it's going to look at the name 8 all the way up to, though not including 18, so ed all the way up to L, and that's our output right here. While it doesn't make any sense to add 2 languages together, here's how we can do it anyways, using the underscore underscore add method. Here's the same class as before. I've added back the REPR method, and I've built another add method. It takes self and other, so those are the 2 objects we're comparing, or not comparing, we're adding. And this time, instead of returning a string or a number, we're returning a new object. We're returning a new instance of the language class, and we pass in a name here. And the name is going to be the name of the current instance concatenated to a string, and then the name of the other object. And here we have 3 objects, or 2 objects, L1 and L2. Their names are Python and Ruby. If I add L1 to L2, we'll see a language called Python Ruby, because we're essentially making a new object, and the name is going to be, well, L1. L1 has a name of Python, so this is going to be Python concatenated to a space and other.name. Now, other.name is going to be Ruby, and which is L2. And we can also make new objects or new variables using the method right here. So L2 plus L1, notice how it's reversed from above. L2 plus L1 is going to make a new language object whose name is Ruby Python, and that's the output right here when we print out L3. The last Dunder method we're going to take a look at today is the len method, which allows our classes or our objects to be used with the len function. Here we have the default class or the original class that we had, and we make a new object with name assembly and print out its length, or at least try to, because we will get an error telling us that object of type language has no len function. So what we do is add the underscore underscore len underscore underscore method, which returns the self.name's length. And in this case, L1 has a name of Python, so when we print out L1's length, that will give us 6, since that's the length of its name. So we'll see 6 is the output of this cell. There are dozens of special Dunder methods that are supported by Python, some of them for type conversion, some of them for comparison, some for arithmetic operations, some for iterations and other stuff as well. And hopefully this lesson has given you some information on how we can use those methods. And these are the methods that we talked about today. In the description, I'm going to leave a link to an official Python documentation where you can get a list of all the supported special Dunder methods. And that's it for this video on Python Dunder methods. I hope you enjoyed this video, and if you did, don't forget to like, share, comment, and subscribe for more programming tutorials like this one. With that said, thank you for watching, and I'll see you next time.